Hello everyone, this question has been taken from Irodov Fundamental Equation of Dynamics, question number 106. A small disk A is placed on an inclined plane. This is the inclined plane, A is the disk. This inclined plane is making an angle alpha with the horizontal, this angle alpha, and is imparted an initial velocity V0. Find how the velocity of the disk depends on the phi if the friction coefficient K is equal to tan alpha and at the initial moment phi naught is equal to pi by 2. So let us work on this problem. Collected the data given in the question here. Initial velocity imparted to disk V0, friction coefficient K is equal to tan alpha, initial moment phi naught is equal to pi by 2. We have to find V as a function of velocity of the disk as a function of phi angle. This is the diagram which I have made is for the initial condition when the disk was imparted a velocity V0 perpendicular to the x-axis as per the question. This is the pi by 2, that is phi naught. Weight is acting downwards, mg. Component of the force along the inclined plane is fx, that is component of mg, so that will be mg sine alpha has been. Mg cos alpha is the component of the gravitational force on the disk perpendicular to the inclined plane is mg cos alpha. Inclined plane has a normal reaction force on the disk that has been shown here. That will be exactly opposite to, so that will be perpendicular to the inclined plane and has been shown here. So along the inclined plane there is no motion at all throughout the motion. There is no motion in the perpendicular direction of the inclined plane. So n will be equal to mg cos alpha. Now we know that friction force will be always act opposite to the tendency of the motion. So tendency of the motion is V naught in this direction. So friction force will be acting opposite to it. That is small f. It has been shown here. So we will calculate for it. F is equal to K into N. By putting the value of N is equal to mg cos alpha. So we are reaching to this place. And finally, we got a result of mg sine alpha. So friction force F is equal to mg sine alpha, but we know that mg sine alpha is the component of the gravitational force acting on the disk in the direction of the inclined planes. And that we have notated by Fx. So it is basically F is equal to Fx. Number 1 equation. Now one important thing to understand how the disk is taking this path. Friction force is always acting opposite to the direction of the velocity of the particle at that instant. So here it is this. Mg sine alpha is always acting along the inclined plane. So because of this unbalanced force, the disk will be coming down, and because of the friction force, it will slow down. It will gradually slow down. So what is happening? Your V is continuously changing. V is changing in magnitude as well as in the direction. So it will take a trajectory of this kind. At an instant when the disk was at this location where it was making an angle phi, the velocity of the disk was making an angle phi with the x direction, has been shown here. So v, since we have to find v as a function of I, so at this location we will calculate for v. As we have seen that friction force F is equal to Fx mg sine alpha. Alpha is constant, mg is constant. So F is always, the magnitude of the friction force is always equal to the F subscript x. Now we will start writing the Newton's law of motion in the direction of the velocity, that is the tangential acceleration we can say, and we are notating it as a subscript t. We can write the equation from NLM as m into a into t is equal to fx cos phi minus f. Is a simple equation because mass into acceleration is equal to net force acting in the tangential direction. Net force will be component of the fx force in the direction of the tangent. So fx, it is making an the velocity fx is making an angle phi with the velocity direction. So cos fx cos phi will be the component of the force along the velocity. So fx cos phi, and uh, just opposite to the velocity is f force is acting. So this will be fx cos phi minus f. And after putting the value, we will be reaching to this solution, this equation. Tangential acceleration is equal to g sine alpha in bracket cos phi minus 1. Same way, we will apply the Newton's law of motion along the x direction. So along the x direction, which all forces are acting? Fx is acting, and component of the friction force along the x-axis is F cos phi. You can see in the previous diagram. And after calculating, we will be reaching to g sine alpha into 1 minus cos phi. That is, acceleration in the x direction is g sine alpha into 1 minus cos phi in bracket. So this is, if we compare with this equation 2, we can easily notice that ax is equal to minus a into 8 a subscript t, means a subscript t. So ax we can write as dvx by dt. Same way at we can write as dv by dt. And there is negative sign, so we'll have add the negative sign over here. So dvx will be minus dv. We will integrate both sides. So what is happening, that we are getting as minus vx plus c. C is a constant. This is from the simple integration. And vx is, we can see the component of velocity in the x direction, that is cos phi, v cos phi. Using the initial condition, we can reach to this c is equal to v naught. And putting this back into equation number 2, we will get v is equal to minus v cos phi plus v naught, or v is equal to v naught divided by 1 plus cos phi. So this will be your answer, because v as a function of phi we got. So this will be your answer. Phi is gradually decreasing. Once it becomes 0, means v along the x-axis, v is along the x-axis, then v becomes, putting the value of phi as 0. So cos phi will be 1, 1 plus 1, 2. So v naught by 2. Further, you can notice that friction force is all the time equal to Fx, that is equal to mg sine alpha. So when the phi is 0, there is no net force acting in, there is no net force acting which can take the disk further up or sideways, because velocity along the sideways also is 0 at when the phi is 0. So what will happen, once the disk once the disk make an angle 0 degree, means along the x-axis, the disk will continuously goes down with a constant velocity, that is v is equal to v naught by 2. That has been written over here. So this is just for analyzing, like, okay, how the motion uh, is there after when the phi becomes 0. So when the phi becomes 0, the disk will no more dependent on phi. Rather, it will be coming down with a constant velocity v naught by 2 along the inclined plane in the direction of x, along the direction of x axis. So hope you understood the way it has been solved, and you can go through the item. You will understand it easily. In case any doubt at any place in the calculation or anywhere, please do let me know through the comment. Thank you.